This is a review of question 1 in exam 4. Question 1 is multiple choice conceptual. Part A, the cart's change of momentum delta px in the figure is which of the following choices? Well, if we want the change in px, that's equal to the final value of p, written as a vector, minus the initial value. The final value is the mass times v final. And then from that we subtract the initial momentum, the mass times v initial. The mass is the same in each case, 10 kilograms, so we can factor that out. V final is plus 1 meter per second. And V initial is minus 2 meters per second. So we have to subtract this velocity. In other words, we have a negative times a negative. So this is 1 plus 2, which is 3, times 10, or 30 kilogram meters per second. Choice E. In part B, a light plastic cart and a heavy steel cart are both pushed with the same force for 1.0 seconds, starting from rest. After the force is removed, the momentum of the light cart is what with respect to the heavy steel cart? That is it greater than, equal to, or less than? Or you can't say. Here the momentum of the cart in each case is changed by an impulse. And the impulse is defined as the average force times the time interval. The average force in each case is the same, and the time interval in each case is the same. So the change in the momentum is the same for each cart. So the answer is D. In part C, we see a fan blade speeding up. What are the signs of omega and alpha? We see from the figure that the direction of the rotation is clockwise. A clockwise rotation is considered a negative rotation. In other words, there is the change in the angle with respect to time is negative. So that means the correct answer is either choice C or choice D. They tell us that the fan is speeding up, which means that the angular acceleration must be, the sign of the angular acceleration must be the same as the sign of the angular velocity. So the choice for this question, the correct choice, is D. In part D of question 1, 3 stars are aligned in a row. The net force on the star of mass 2m is to the left or to the right, or 0, or not enough information to answer. Well, we see that there is a force due to the 5m mass pulling it to the left, and a force due to the 1m mass pulling it to the right. So let's calculate each one of these, or at least show how we would calculate it. The force due to the mass on the left is equal to G times the mass on the left, which is 5m, times the 2m mass, divided by the distance separating them, squared. Let's count that separation distance. Let's see, 1, 2, 3, 4 units. So we see that this is equal to 10 over 16 g m squared. We repeat the same procedure to find the force on the middle mass due to the right-hand mass. So it's equal to G times the mass of the right-hand mass, which is M, times the mass of the middle mass, which is 2m, over the separation distance squared, which is 2 units. This is equal to 2gm squared over 4, or 8/16, which is less than the force on the left. So the correct answer is choice A. And that concludes this review of question 1 in exam 4.